Hi, everybody. Today we're going to talk about fibers. This is our second lecture, and we're going to talk about what fibers are, and we're going to talk about the terminology that we need to know about fiber properties and things that you need to understand what fabrics are about, how they behave, and so on. Now, a fiber is the fundamental unit from which textile products are made. So it is the basic unit that we make yarns from, and then we make fabrics out of yarns and so on. There are two main categories of fibers that are natural fibers, and these are fibers that we can find in nature in fiber form. They can be plants, they can be animal hair, they can be seeds that bloom. So there are a lot of different things we use in nature as natural fibers. And there are also manufactured fibers. Those are produced from either raw materials found in nature, or we synthesize them from petroleum or other byproducts. And synthetic fibers or manufactured fibers generally look more like chips like this. For example, these are polyester chips that we use to make fibers, yarns, and fabrics. Now, polyester or any manufactured and synthetic material is basically a very large molecule that is made by connecting many small molecules together. So this, for example, is ethylene. It is 2 carbons for hydrogen atoms. And when you break that bond and you just keep mixing them all together, they create a long polymer like this. And those long polymers are generally what make up a lot of the manufactured fibers that we can make in a lab, basically. So you put a lot of ethylene molecules in a cup, and then you let that bond break, and then all of those ethylenes kind of connect to each other like that, forming this long chain of a molecule, and many fibers are long chains of molecules. These are some more examples. This is a cotton ball, a natural fiber, a raw wool fiber, which is natural, a silk cocoon, which we use to make silk fibers. These are all natural ones. And on the bottom are all the synthetic or manufactured ones, like polyesters, olefins, and so on. Now, what we are going to do is we're going to study all the natural fibers, cellulosics, protein fibers, and others. And then we're going to go into manufactured fibers. And we have cellulosic manufactured fibers, we have protein manufactured fibers, but majority of the fibers that you guys know, like polyester and nylon, are in the synthetic category. To be able to understand these fibers, you need to understand the terms we define them, or the properties that we talk about when we talk about fibers. So these are the 6 properties that are related to the physical structure of fibers: the length of a fiber, the diameter or fineness, the cross-section, surface contour, crimp, luster, and color. So the length is basically how the fiber looks like in length. So for example, cotton fibers, when you open them up, they're going to be very, very short little fibers like that. This is a cotton ball in the field. And if you pull out each of these fibers and put them all parallel to each other, you're going to see that cotton fibers are pretty short fibers. You don't get anything long like a long hair, right? But synthetic fibers are a little bit different. Because we manufactured them, we can make them as long as miles and miles. You know, whatever you wind on this bobbin might be just one single fiber, which makes the whole yarn. And we call these filaments because of that, because filaments are made all at once, and it's a long, long fiber. But these short fibers, we call them staple fibers, okay? And sometimes we take filaments and we cut them into staple form because we blend, for example, polyester and cotton together. To be able to blend them, you have to cut them short and make them almost similar in length so that they can be blended. So these are synthetic fibers that are cut into staple sizes or short sizes, okay? And if you look at all of these, they are pretty shiny. Natural fibers are usually much more dull. They don't have a luster to them, but synthetic fibers are usually a little more lustrous. And you can see that they are also pretty smooth. Again, this is a natural staple fiber, and this is a manufactured staple fiber. And this fiber that is manufactured is already also crimped like this to give it that kind of wavy shape. And I added all this information just in case you don't read your book and you have all that information to read off of my slides. But I'm going to also show you some of the lecture slides on iTextiles, and you can get a lot of really good pictures to understand some of those properties better. Now, diameter is the diameter of each fiber when you look at them under a scanning electron microscope, for example. This is basically giving us an idea about how thick a fiber is, right? Silk is usually 11, 12 micrometers. Cotton is a little bit larger than that, and wool usually has the largest diameter. And denier is a measure or text. Those are measures that we use. For example, if you guys were making t-shirts and you have to order t-shirt material like a jersey fabric, you would have to tell the manufacturer what size yarn to use to make those fabrics, right? So to be able to explain what size yarn, there are certain standards that we use. So you can either use micrometers for the diameter of each yarn, or you can use the denier measurement. And the denier is the weight in grams of 9,000 meters of a yarn. So you take 9,000 meters of a yarn, you put it in on a scale, you weigh that in grams, and if 9,000 meters of a yarn is heavy, so if it's like, 20 grams, and that means it's a thick yarn. If it is only 1 gram, that means it's a very fine yarn. So the weight in grams of 9,000 meters of a yarn will give you an idea of whether a yarn is fine or coarse. Okay. And there's also the English system where they count that in yards instead of 9,000 meters. And there's a metric yarn count system where we take 1,000 grams of the weight of a yarn, we put it on the scale, and then we measure how long it is. So if a 1,000 gram yarn is very long, then that means that it's not very heavy, right? If it is a short yarn that already gets us to 1,000 gram weight, that means it's a coarse yarn. So that's kind of how those systems work. There's a difference between fiber diameter versus yarn diameter because yarns are made out of multiple fibers. Now, apparel fibers are generally 1 to 7 denier, and they are fine. We use microfibers. Those are usually less than 1 denier. They are the super fine fibers that we see on upholstery. When you touch them, it's super soft. And then carpets are, of course, much coarser. So they use 15 to 24 denier in yarn diameter. Now, again, fiber and yarn is different. So micrometer is probably more suitable to measure. So now the cross section of a fiber is when you take a yarn and then you cut it and you look at what it looks like in that in the middle. So this is the cross section of a yarn that is cut out like this. The surface contour is the surface of the yarn. Some yarns have a smooth surface, some yarns have a twisted surface, and all of those things, the cross section of the yarn, the shape of that cross section, and the surface contour, and also the waviness of the yarn, which we call crimp, those are the things that add to their properties, So a crimped yarn will perform differently than a smooth yarn. Now again, natural fibers, you don't have much of a change you can make with natural fibers because they come in nature in that way. So cotton fibers are always going to be the way they grow in the field, or wool fibers are going to be the way they grow on the sheep. But man-made fibers, you can control the shape and the cross-section, the surface contour. You can control a lot of things because we usually make them using these spinnerets, which are kind of like shower heads, and then you push the melted solutions out of them and they come out like that. They dry, they make up your fibers. Okay, so based on the shape of the hole on the spinneret, you know, you can make them circular, you can make them round, you can make them hexagonal. Your fiber shape, fiber cross-section shape is going to be different. And it will also affect your longitudinal surface. Cross-sectional shape affects the luster of a yarn, the bulk that you get from that fabric when you use that yarn, the body, the texture, the hand. And when I say the hand, you know, we call it hand when you touch a fabric and it's the way it feels to your hand. You know, some fabrics have a better hand than others and so on. So this is an example of a Y-shaped cross-section, and that's a man-made fiber, and they made the holes on the spinneret in this shape, so the fibers came out in this shape. Or you can make it like a little star like this as well, okay, depending on how you extract the fibers. Surface contour affects cohesiveness, luster, opacity, hand. So if you look at different types of fibers, they all have different surface contour. This is a nylon fiber. It's usually very smooth because it's manufactured. It's a synthetic fiber. It can be circular or it can be in dog bone shape. You can make voids in it like this, and you can create it in this shape. Or you can create it in a triangular cross section. Silk generally naturally has a triangular cross section, and it has a pretty smooth surface. This is flax. Flax is the fiber to make linen fabrics, and the fiber usually has knobs on the surface, and it has kind of a hexagon, polygonal cross section to it. And then wool looks just like our hair. It's usually round and it has scales around it. So the luster, the color, those are all affected by the way you make the fiber or the materials that the fiber is made out of, right? Luster can affect physical appearance of the fiber, yarn, and fabric, and color affects the bleaching and dyeing of fibers. The color for natural fibers can be usually an off-white color, but then we bleach them and then we dye them to whatever color we want. So we talked about polymers a little bit. Again, polymers are the main components of manufactured fibers, and the chemical composition and the length of the molecular chain is important. So for example, this is an ethylene, and then you repeat it 15 times, you get a polyethylene. So I'm gonna skip this for a second because I want to go through your iTextiles a little bit. And I'm just gonna show you a couple of things, you know, again, cross section and surface contour of a fiber. You can see the fiber length of different fibers. You know, this is 2 inches long, this is 4 inches long, this is 18 inches long. And these are usually, anytime you see a long, long fiber like this, it's probably a synthetic or manufactured fiber, because natural fibers are generally not long except for silk. And if you see that kind of color and crimp, it's probably wool. If you see any luster like that, it's probably a synthetic. Again, these are different fiber contours, surface contours for different fibers. This, I can tell this is a cotton fiber because cotton has this twisted like convolution type surface. I can see this is wool because of the scales I see in it. This looks like a synthetic fiber because it's very smooth, and so on. You know, most of the time, if you see the pictures of the fiber, you can see what you can tell what it is. Cross-section, again, affects the properties of the fiber. You know, if you have a hollow cross-section like that, those fibers are generally very insulative. So we use them in winter coats or sweaters and anything that you need to insulate your body with. If it is round, for example, it has more shine to it because the surface is so smooth, it reflects the light more. So all of these surfaces will affect how the fiber performs. For example, if you have these we call these trilobes because it has 3 lobes like this here. Now, when you have something like this, the dirt generally goes into those middle points. So on the surface, you don't see a lot of the dirt. So this kind of cross-section usually hides dirt on the fabric. Okay. And we talked about fiber diameter a little bit, so I'm going to pass those. These are different levels of luster you can see in fibers. Lyocell, rayon, elzon, cultivated silk, linen, and then wool and cotton look like the dullest of all of these. And you can see the actual fibers here, you know. So this is probably a plant-based fiber, maybe flax fibers. This looks like wool, this looks like a synthetic. So you can see the colors of fibers. Cotton is generally off-white. Wool generally comes in the color of the hair of the sheep. Synthetics are usually, you know, like this color or transparent a little bit. So it really depends on your source. The crimp of the fiber is the waviness of the fiber. So some fibers have crimp. It's almost like, you know, some people have wavy hair, some people have smooth hair. So it can be like that for wool, for example. And sometimes we actually add crimp to the fibers because the crimp affects some of the properties of the fabric. Linen or flax fibers are usually pretty smooth and they don't have any crimp. So before I get to this, let me go back to the slides again. These are polymer properties, which I don't want to confuse you a lot with at the moment, but polymers are made out of those long molecular chains. And when the chains are very parallel to each other, they are more crystalline and they are a lot stronger. So it's harder to break those type of fibers. But if they're a little more mixed up and kind of like these molecular chains, then it's easier to break them. It's not as strong. So all of those little things and the chemistry of the fiber affects the way it behaves. Okay. There are generic names and trade names for fibers. So for example, Lycra is a trend name. It has that R here, which means it's a registered trademark. And Lycra was developed by DuPont. This is the company. And it's actually spandex, but if it is made by DuPont, DuPont calls it Lycra. That's their special brand. So Gore-Tex is another trend name like that. Kevlar, Nomex, these are actually, the generic name for these fibers are aramid fibers, but different companies make them in different ways and they have those trade names for them. These are the generic chemistry names. So for example, polyethylene means we polymerized ethylene and we call it polyethylene. Polyethylene terephthalate is the polymerization of ethylene terephthalate, which we shortly call polyester. Nylon has this official chemical name, but we use nylon or nylon 6 as a generic name. Okay, now we're gonna go through all these fiber properties. So guys, we already covered fiber properties with you in first class. We talked about fiber properties that affect the aesthetics of a fabric, like the drape and fineness, flexibility, wrinkle resistance, opacity, crimp, resiliency. And we talked about comfort properties like insulation, absorption, wickability, elongation, elasticity, static buildup, and so on. And in terms of durability, we have properties like tenacity, abrasion resistance, weathering, and so on. So I already mentioned all of that in the first class. So I'm going to kind of go through them really quickly. And I'm also going to mention some of the care properties like ironing, washing, storage of fibers. Okay. We talked about cover. So, you know, it's the ability of a fiber to conceal something that's behind it. Translucence is the ability of a fiber to allow light through it. You know what luster is, you know what drape is. It's how the fabric flows. Texture is nature of a textile surface. Hand is how a textile feels to the touch. We talked about abrasion resistance. It's the ability to withstand rubbing and folding of a fabric. Flexibility is the resistance to flexing the fabric or bending it repeatedly. Pilling is the formation of those tiny balls on the fiber. We talked about tensile strength or tenacity. It's the same thing. And I showed you the machine that we use to measure tenacity. It's basically the standard that we measure to see how strong a fiber or yarn or fabric is. So tensile strength or tenacity is basically the strength of a fabric to withstand a heavy pulling force before it breaks or tears. Cohesiveness is the ability of fibers to cling together to make the yarn. Elongation is when you stretch a fabric, does it keep getting a little bit longer without breaking? Absorbency is the ability to take up moisture. So there are two major terms that you guys need to know about absorbency. Hydrophilic means water loving. Hydro comes from the Greek term water and philic means loving. So hydrophilic means loving water, absorbing water. Whenever you see water, you just absorb it and take it in. So hydrophilic fabrics are very absorbent. Hydrophobic means water hating, basically. So you don't like water, you don't absorb water. So when you drop water on hydrophobic fabrics, the water just beads up on the surface. It never gets absorbed into the fabric. Another term we use for absorption properties is hygroscopic. And this is the ability to absorb moisture without feeling wet. So this is the difference between a cotton shirt and a wool shirt. If you have a cotton shirt and you just drop a glass of water on it, you're going to feel wet. Your fabric is going to feel wet. It's going to get wet. But if you have a wool sweater and you drop some water on it, you usually don't really feel that wet. And you can't see the wetness on the sweater. So that kind of fabrics are hygroscopic. Dye ability is the receptiveness to coloration by dyes. Electrical conductivity is the ability of the fabric to conduct electricity. Wicking is a little bit different from absorption. Wicking is the ability to transfer moisture along the surface of a fiber. So it's a little bit different than absorption. Heat or thermal retention is the ability to hold heat. Conductivity of heat is the ability to transfer heat. Heat sensitivity is the fiber's reaction to heat. Flammability is how it reacts to ignition or flame, how it burns. And we talked about a lot of those things, so I don't want to go over too much, but I'll emphasize the important ones that you guys all need to know. Resiliency, for example, is when you crush something or bend it or twist it, does it return to its original shape without wrinkling, without breaking, bending, and so on. So resiliency is very much related to wrinkle resistance, crush resistance, and so on. Compressibility is the resistance to crushing. Loft is the ability to spring back to the original thickness after being compressed. So resiliency, we usually look at the entire surface of the fabric, but loft is more about the thickness of the fabric. If you compress it in that direction, does it go back to its original thickness? Dimensional stability is the ability to keep the shape, not to shrink. Shrinkage resistance, again, is the ability to retain the size. And now elasticity or elastic recovery, those are the same thing. This is the ability of extension, but when you extend a fabric and it gets longer and you release it, does it go back to its original length or does it just elongate? So some fabrics, when they don't have good elasticity, they may have good elongation, but they don't go back to its original length. Creep is delayed recovery from elongation. We talked about aging resistance, resistance to environmental conditions, mildew, moth, or insects. So there's more description of all of these terms here. One thing you should know is oleophilic or oleophobic. This means, this is about the affinity for oil. So oleophilic means loves oil, absorbs oil, and gets stained by oil. Oleophobic means it repels oil and it doesn't get absorbed by oil. In a diaper, you know, those kind of properties are important. Ability to absorb moisture, you know, absorbency, and so on. Chemical properties obviously are important when you are washing or dry cleaning, like resistance to acids, alkalis, oxidizing agents, solvents. Biological properties are more about resistance to microorganisms, insect damage, and then effect of heat, flame, UV light. You know, those are important fiber properties that define how a fiber or a resulting fabric reacts. And if you guys go to your iTextiles, it explains to you all of these terms as well. It gives you some pictures. For example, this shows you elongation. So elongation is basically, you know, you measure the length of a yarn and then you just keep stretching, stretching, stretching until it breaks. And that breaking point is how much elongation it has. Elastic recovery is the ability to return to its original length. So when you measure the length and then you start stretching, stretching, stretching to see how far it goes. And then when you release it, does it go back to the initial length? You know, this is elastic recovery or elasticity. If it doesn't go back to its initial length, that means it doesn't have very good elastic recovery, but it may have a lot of elongation. We talked about resiliency. Again, this affects wrinkles and crush resistance and so on. Flexibility of a fiber is the ability to fold or bend. We talked about all of these. Now, this is a good example of hydrophobic, where the water doesn't get absorbed into the fiber. It just beads up on the surface. You see that it's not absorbed. This is a hydrophobic fiber, but this one is hydrophilic, where you drop the liquid and it just gets absorbed all the way in. This is an oleophilic shirt fabric, and you can see that the oil stained that shirt. That means it has affinity for oil. This is an example of mildew on a cotton canvas bag. So you see that mildew is darkening the fabric a little bit and causing some damage on the fabric. This is moth damage on a wool fabric. So moths are those bugs that eat up wool. Wool is protein, so they kind of like protein. They eat it up, and then you will get holes like this on your sweater sometimes if you don't use mothballs. Silverfish is this little insect that you can see in cotton, especially if you store your cotton t-shirts, for example, in a basement where it's moldy and wet. Those silverfish will come out and start eating up your shirts and damage them. This is an example of exposure to sunlight, which degrades degraded silk curtains. This is the effect of heat and flame. Some fabrics burn into ashes, some fabrics melt. So, you know, those are properties that are important when you're evaluating fibers. Okay, this is all I have for today, and I'm going to see you next week.